Well, in here, M can explain about proof method and strategy. This method is based on a rule of inference that we will now introduce to prove a conditional statement of the form P1 or P2 or up to or Pn if Q. The tautology P1 or P2 or up to or Pn if Q. If and only if P1 if Q and P2 if Q and up to and Pn if Q can be used as a rule of inference. Next, substance exhaustive proof. Some theorems can be proved by examining a relatively small number of examples. Such proofs are called exhaustive proofs or proof by exhaustion because this proof proceeds by exhausting all possibilities. An exhausting proof is a special type of proof by case where each case involves checking a single example. We now provide some illustration of exhaustive proofs. Example. Question. Prove that n plus 1 rank 3 more than or equal to 3 rank n if n is a positive integer with n is less than or equal 4. Solution. We use a proof by exhaustion. We only need verify the inequality n plus 1 rank 3 more than or equals to 3 rank n. N is 1, 2, 3, and 4. For n equals 1, we have n plus 1 rank 3 equals 2 rank 3 equals 8 and 3 rank n and 3 rank 1 equals 3. For n equals 2, we have n plus 1 rank 3 equals 3 rank 3 equals 27 and 3 rank n equals 3 rank 2 equals 9. For n equals 3, we have n plus 1 rank 3 equals 4 rank 3 equals 64 and 3 rank n equals 3 rank 3 equals 27. For n equals 3, we have n plus 1 rank 3 equals 4 rank 3 equals 64 and 3 rank n equals 3 rank 3 equals 27. For n equals 4, we have n plus 1 rank 3 equals 5 rank 3 equals 125 and 3 rank n equals 3 rank 4 equals 81. In each of these 4 cases, we see that n plus 1 rank 3 more than or equals to 3 rank n. We have used the method of exhaustion to prove that n plus 1 rank 3 more than equal to 3 rank n if n is a positive integer with n is less than or equals 4. Okay, next material. Proof by cases. A proof by cases must cover all possible cases that arise in a theorem. We illustrate proof by cases with a couple of examples. In each example, you should check that all possible cases are covered. Next material. Leveraging by cases. The example we have presented illustration proof by cases provides some insight into when to use this method of proof. In particular, when it's not possible to consider all cases of proof at the same time. A proof by cases should be considered. When should you use such a proof? Generally, look for a proof by cases when there is no obvious way to begin a proof. But when extra information in each case help move the proof forward. Without of generality, where x is less than 0 and y more than or equals to 0, because it is the same as case 2, where x more than or equals to 0 and y is less than 0, with the rule solve fx and dy reversed. To certain the proof, we could have proved cases 2 and 3 together by assuming without loss of generality that x more than or equals to 0 and y is less than 0. Implicit this statement is that we can complete the case with x is less than 0 and y more than equals to 0 using the same argument as we used for the case with x more than or equals to 0 and y is less than 0, but with the obvious change.